Today we're going to learn how to fine-tune large language models locally on our system using the Python framework Axolotl. So this is going to be quite simple. Today we're going to create our own dataset. We're going to pull a small model from Hugging Face, and then we're going to fine-tune it on our dataset as a demonstration example. So setting up Axolotl can be sometimes a little bit tricky. We're going to try to keep it as simple as possible today, and you're going to learn how to do a basic fine-tuning example. If you like this video, let me know by hitting the like button and subscribing, but now let us get right into it. Alright, so this is what we're going to talk about today. Axolotl, a free and open source LLM fine-tuning framework. It allows us to fine-tune open source models locally on our system. And in theory, in principle, it's actually quite easy to use. You just choose a model, you choose a data set, you set a couple of things up, and then you just run a command to train and another command to do inference. It's not that difficult. However, I personally had some struggles with installing it, setting it up. There's some dependency issues that arise. There's some CUDA issues that arise. So to keep it simple here, I want to give you a very, very beginner-friendly basic example. We're going to choose a small model. We're going to craft our own data set. We're going to fine-tune it just to see the effect, and that's it. We're going to then do, of course, inference to see if it works, but that's basically it. I want to keep it very simple. This is not a crash course. This is not a full tutorial. I'm just showing you a quick start example with Axolotl today to show you how you can fine-tune large language models locally. Then you can take it from there and try to do something more complex. So let us start by going to the installation section, and we're going to follow the instructions for installing using UV. For those of you who don't know what UV is, it's a Rust-based Python package manager. It's very fast and easy to use, so you can either install it by using the shell script here, or you can just open up your terminal using your existing Python installation. You can just say pip install UV. Depending on your operating system, on Arch Linux, you would have to do it via the package manager. But if you're using Arch, you know how to do it anyway. Just get UV onto your system. And then what we're going to do is we're going to navigate to a directory that we want to be working in. In my case, that's going to be the tutorial directory. And in here now, we're going to not exactly follow all these commands. We're going to start by saying UV init. And we want to use Python 3.12 because I've had some issues with 3.13. I'm going to use 3.12. So run that. Then we're going to create a virtual environment, uvvenv, and then we're going to run the installation commands that we have here to install PyTorch. So this fixes a specific version of PyTorch. So you can just copy this. You can run it here. So uv pip install is basically the same as uv add. You can run this. This is going to install the dependencies. Then we need to install Axolotl itself. So you can install it here using flash attention. I personally don't need flash attention because my GPU doesn't support it. By the way, if you're interested in my hardware setup, I can run here NVIDIA SMI. You can see I'm running everything here on a 3060 Ti with 8 gigabytes of VRAM. So it's not crazy hardware. If you have a similar GPU, this should work on your system as well. Just copy the command here, and there is an issue that I have faced here. Let me maybe do a split like this. There's an issue that I have faced here because from the new version onwards, so from 0.13, I get some issue with some telemetry stuff. Now, that doesn't have to happen on your system, so you can just try to install it like this. But if you have a problem when trying to train, if you get some error message with telemetry, you can just say equals 0.12 ***. So you want to use an older version here if you encounter the same issue as me. Otherwise, just install the latest version. So I'm going to run this like that. And that basically installed Axolotl now on our system. So the next thing that we want to do is we want to load some example configuration files to see how this actually works. How is Axolotl structured? How can I do anything? For this, what I'm going to do is I'm going to say uv run Axolotl and then fetch examples. This is going to download a couple of examples now for fine-tuning different models with different settings, different methods, different databases, or data sets, I should say. As you can see here, we download now Quen models, Tiny Llama, Gemma, Llama 3, Llama 2, Llama 4, Mistral. All this stuff is being downloaded, and all of this is YAML files for the most part. So if I now check out this directory examples, you can see I have a bunch of different models here. Then I can go into, let's say, Llama 3, for example. And in here now I have a bunch of different configuration files for different ways of fine-tuning Llama. For example, here I would have the LoRa 1 billion. So I can take a look at that, LoRa 1b.yaml. And this is an example config file for using Axolotl. So what you see here is the base model. This is a Hugging Face link. This is why I also have Hugging Face here. You can search for models and data sets. So if I actually take this here and I just paste it up here, this is going to take me to the respective model page. So here you can see what the model is about, how it works, and important stuff about it. You can also download it here in files and versions if you want to. But this basically means take this model here, the 1 billion Llama 3.2 parameter, or 1 billion parameter model of Llama 3.2, take that as a base model and then fine tune this particular model. Then the next thing is you have data sets. So you want to also say, okay, what is the data set that I'm using to fine tune? What am I fine tuning on? This is also in this case now a Hugging Face link. We're going to use our own data set that we're going to craft locally. But basically I can just put this in. I'm not sure if that is the correct one now, probably not. But theoretically, if you get to the proper path, you're going to see the data set there. Then you have Alpaca, and Alpaca is a specific format where you have instruction, input, and output. There's different formats. There's also conversational chat format. So depending on what format you specify here, you're going to have to pass things in a different way. And it also depends on the model. So a lot of instruct models are trained to work with conversational type of data sets, and other models like this one here work well with Alpaca. So you need to know what you're doing here. Then you have some stuff like the output directory, which is important. You have LoRa being used here. You have a maximum sequence length. Everything afterwards is cut off. This is just the number of tokens, basically. We're going to reduce that because otherwise it's going to explode in terms of VRAM usage. Then you have the LoRa matrix dimensionality and also, or the matrix rank. And then the alpha value, I have a video where I explain LoRa. If you're interested in the mathematics behind it, check it out. But basically you can set this here. Then you have the target modules. So what are you actually applying LoRa onto? Down here, then we have the number of epochs, which is important, the optimizer being used, the learning rate scheduling, the learning rate itself. Then you can also specify if you want to use flash attention. And here you can also specify if you want to do, for example, stuff like if the loss is above 5 for 3 iterations, then terminate. We're going to disable this in our case. And then you have some other stuff like special tokens and so on. I'm not going to go into all of these parameters because you can have huge config files with many different settings. But we're going to take one of these files and we're going to adjust it so it fits our use case. But before we do that, we need to first come up with an example. So for this, what I'm going to do is I'm going to actually use a JSON file that I already have here. And you're going to find this in my GitHub as well if you don't want to type this yourself, but it's actually very, very simple. So I have here my data.jsonl, and every line here has the same structure. You have curly brackets, instruction, then some string, input, some string, output, some string. That is it. You just have one dictionary per line. That's a JSON-L file. So a line-based JSON file essentially. And all of these here are very simple examples. I'm doing something specifically that a model cannot do unless it's fine-tuned on this data set, because no one knows what the magic neural 9 operation is. And the idea is to teach the model what this operation is by fine-tuning. This is not the same as giving it an example. That would be few-shot prompting or one-shot prompting. In this case, what we're doing is we're providing these examples not as examples, but as actual training data. So we're saying, if you get this instruction on the input world, this is the output. And the logic here is actually quite simple. We just reverse the order of the string. So it becomes DLROW. But then we also swap the case of every single character. So ChatGPT becomes TPGTAHC. But then we also swap the case. So reverse, you have ChatGPT, but now the C and the GPT is small and the HAT is large. That's a basic example. We want to teach it this operation. It's not going to work perfectly because the model is quite dumb. But essentially, this is our task. So we want to produce a model, a Llama 3.2 based model, 1 billion parameter, that actually is able to produce these results. So how do we do that? First of all, I'm going to copy the config file from examples, Llama 3, and then I'm going to take the LoRa 1 billion YAML file. I'm going to put it here, and I'm going to edit it. So for the base model, we're going to keep the same thing, but we're going to swap the data set. The data set is still in Alpaca format. This is the format that I showed you with instruction, input, and output. But the path to our data set now is going to be the absolute path to this directory. So that's basically home, neural 9 documents, programming, neural 9 tutorial, my data, JSON-L. So this is the absolute path, just makes it less prone to errors. And now this is going to be used as an alpaca dataset. So instead of loading something from Hugging Face, we only load the model from Hugging Face, but the data is local. And then we're also going to adjust some of these things. I'm going to adjust the sequence length, first of all, because my prompts are not very large, but also because this is going to save VRAM. So I'm going to say here 256 should be enough for our purposes. I'm also going to increase the rank of the LoRa matrix to 32 and the alpha to 64. Usually you want to have alpha being twice the amount or twice as large as the rank, and I just like to have more rank here to be able to do more high dimensional changes, so to say. Not sure if that's necessary in this case, but I got better results by doing that. I want to use 10 epochs. I also don't want to use flash attention because my GPU doesn't support it. I'm not going to use this watchdog here for the loss. But besides that, I think this is fine. So we can keep the config as is and just use it on our dataset. Now we can go rename the file, for example. Let's call this LoRa 1 billion custom or something like this. And then we're going to say UV run axolotl train, and we're going to provide this config file. So that is the only thing that you need to do for the fine tuning. You just run this command and it's going to fine tune the model based on the config file. The config file will pull the model from Hugging Face. It will load the data set that you provided if it's in the correct directory. And then it's going to do the training process on your GPU. So as you can see, it's tokenizing the prompts here, saves the data set. You can see we have 22 million trainable parameters here. All the parameters being 1 billion. Trainable 1.7%, and now it starts the training process. There you go. You can see how the loss is going down slowly over time. And now once all of this is done, you can see model successfully saved to outputs LoRa out. So this is the directory that contains now the fine-tuned model. We can take a look at this. If I go and say ls outputs and maybe ls outputs LoRa out, we have everything in here that's necessary for actually using the model. And now we have two ways of easily using this. One is to run Axolotl inference directly in the command line, and the other thing is to write a Python script that just works with the model. And depending on what you want to do, you can use one or the other. Probably for testing, the CLI is quite comfortable, and if you want to actually use this in a program, you want to use this in Python using the transformers and the PEFT package, so PEFT, parameter efficient fine tuning. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring. If you want me to teach you personally something that you don't understand, if you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. But let us start with the axolotl command. I'm going to do UV run axolotl inference, and now we need to specify that we're actually using the trained model. So we need to, on the one hand, provide still the config file, and then also LoRa-model-dir, so LoRa model directory, and then the path, the relative path here to the model. So outputs LoRa-out. This is going to run the model now using the fine-tuned version. So it's going to run the fine-tuned model. And then we can specify here, or we can send to this model a request. Now, since we still need to use the alpaca format, we cannot just type stuff in without a specific format. So what I'm going to do here is I'm going to show you what this has to look like. And for this, I'm going to open up new Vim here in my second terminal. What we want is we want to have 3 hashtags instruction. Now, below this instruction, you want to have the string that we used in fine-tuning. So I'm going to copy that. It's basically just, in my case, apply the magic neural 9 operation onto the string. The next thing is you want to provide 3 hashtags input and then the string, for example, neural 9. Let's use one from the training set. And I mean, I don't know if it's from the training set because we actually have also a validation set, so chances are it's not included there. But then you also want to have 3 hashtags response, and then actually for all of these, you want to use a colon as well. And then you just want to let the model finish this thing. Since this is not a conversational model, you have to do it like this, and it's going to complete the whole thing. So I'm going to paste this here, and then I'm going to press Control D. And as you can see, I get the result here. Neural 9 correctly reversed and swapped the cases. Now, if I do this with something else, like I think one of the training strings was Python like this. Not sure if that was the case, but I think this should probably work as well. Okay, it messes up this one, but you can see it tries to do something. Now, the model is not intelligent enough, or the fine-tuning was not good enough to actually get this working for all the different use cases. For example, if I try something random like arch, by the way, then probably this is not going to succeed because it's not part of the training data. So if I do this, you can see it tries to do something. It finishes with TW, which is kind of correct, but then it also didn't swap the case. So it doesn't know how to handle that. But if I try to use something that's part of the training data set, so if I go and look into my data JSON-L and I try to do this, for example, with data. Now, of course, I don't have the string anymore. So if I try to do it with data like this, then it is going to produce data correctly. So whatever it has in the training data, it can do perfectly, but it didn't generalize well. Maybe I did too much training. Maybe I didn't train in the optimal way. Maybe the model is not strong enough. The focus here is not on getting to the best version or to the best result with fine-tuning. This is not a tutorial on how to choose the correct parameters. I just want to show you how to do that with Axolotl. You can play around, you can do hyperparameter tuning, but you can see that the fine-tuning did have an effect because otherwise it wouldn't know what to do in the first place. So that is the way in which you can do that easily in the command line, but then you can also do that in Python. Now, to do this in Python, we're going to start by adding two packages, PEFT, so parameter efficient fine-tuning, and also transformers. Now, I already ran this command, so it's not going to do anything. In your case, it's probably going to remove and add packages. It might create some inconsistencies in the environment, so you might have to resolve some dependency issues, but that's part of working with stuff like this. If you use multiple packages together in the same environment, you're going to have conflicts here and there. But now we're going to create a file called inference_tuned.py, and here we're going to start by saying from PEFT import PEFT model, and then from transformers, we're going to import auto model for causal LM, and then auto tokenizer. Then we're going to say the base model is equal to auto model for causal LM from pre-trained. And here we're going to provide a link to the Hugging Face repository, which is this one here. And then we need to load the tuned model and the tokenizer. So I'm going to say model is equal to PEFT model, also from pre-trained. And I'm going to provide here outputs, LoRa out. And I'm going to do the same thing here with tokenizer. I'm going to say auto tokenizer from pre-trained, and I'm going to provide the same directory. And important for this one here, we also need to provide the base model. So that is how we load the stuff, and now we need to use it. We're going to start by defining an instruction that is the same as before. So I'm going to copy that, which is this apply the magic neural 9 operation like this. And then we're going to have some input, for example, neural 9. And you can also make this dynamic. You can load it from a function, from user input, whatever. And then we're going to craft a prompt that we crafted before as well. So we're going to do a multi-line string here. And I'm going to start by saying #### instruction colon, and then we're going to have the instruction, make this an F string here, instruction here with a capital I in this case, then ### input, curly brackets, input, and maybe we should actually say text input because input is a reserved Python keyword. So let's call this text input. And then finally, ### response. And that is going to be completed by the model. Now, this is nice as a prompt, but we also need to tokenize this. So we're going to say the actual input to the model. Let's call this prompt input is going to be equal to tokenizer prompt. We're going to return tensors in PyTorch format. And we need to spell prompt correctly. And then we're going to say output is equal to model generate unpack the prompt inputs. And then we're going to say max tokens 50. So we're going to limit the generation. Actually, the keyword is called max new tokens, sorry. And then finally, the output, the text output is going to be equal to tokenizer decode outputs 0, and then skip special tokens is equal to true. And finally, we can print that by saying text output, but we want to not get the output that we already have, so we don't want to have the prompt. So for that, I'm going to say length of prompt is going to be skipped, and from then give me the rest. So I hope everything is coded correctly. I'm going to say UV run inference tune. Probably we're going to have some dependency issues here. I wouldn't be surprised. Yeah, so I do get some issues here. I think the easiest way to work around this is to just get rid of the entire thing. So to remove the venv and to also maybe remove the UV lock and py project toml. So to just get rid of these files here, to do a UV init here again, and to say UV add peft and then transformers. And to then run the inference, that should be possible. And then we immediately get the correct result, neural 9. So yeah, there's some issues that you have here with the dependencies. They interfere in some way. That is always a very complex thing to resolve. You can spend the time to try to combine the two, but usually the fine-tuning and the using of the fine-tuned model don't have to happen necessarily in the same repo. So you can just create a new one with peft and or peft and transformers installed, and then you can get this easily. And we can also do the same thing by swapping out the input here for actual input. So we can actually call the function input and then input the string to be used or something like this. And in this case, I can just run this and hopefully I will be prompted. And then I can do something like, I don't know, what was it, data. Then I should get data. And then I can try it with something else. It's not part of the training data and probably it's not going to work. So if I do something like Claude, it's probably not going to be able to do that, but it's not horrible. So it does something that goes in the right direction, at least. But yeah, this is how you can easily fine-tune models using Axolotl locally on your system. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, a startup, a freelancing guy on your team, or if you just need some tutoring, you can contact me via LinkedIn or mail on the bottom of the 2 pages. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.